In this video, we're going to look at Isaac Newton's first and second laws of motion, as well as the ideas of circular motion and inertia. Newton's first law basically says that a resultant force is required to change the motion of an object. Or in other words, if there isn't a resultant force, then the object's motion won't change. And this principle works for both stationary and moving objects. This means that if the resultant force on a stationary object is zero, or in other words, there is no resultant force, then the object will remain stationary. And if the resultant force on a moving object is zero, then it will carry on moving at the same velocity, because in both cases, there's no resultant force acting on the objects, and so their motion won't change. In contrast, Newton's second law says that if a non-zero resultant force acts on an object, then it will cause the object to accelerate. And remember, non-zero just means anything other than zero. For example, if we took this particle and we drew some unbalanced force arrows on it, we can see that there would be a resultant force to the right, because the right arrow was bigger than the left arrow. So this particle would accelerate to the right. Now, the confusing bit here is that depending on the initial motion of the particle, this acceleration to the right could result in 5 different things happening. For example, if the object started off stationary, then the acceleration would cause it to start moving to the right. And if the object was already moving to the right, then it would cause it to speed up. However, if the object had been travelling to the left, then the rightwards acceleration would cause it to slow down, because it's acting in the opposite direction. And if the object was travelling to the left more slowly, it could cause it to stop moving entirely, because it was slowed down so much. The other part of Newton's second law is that the size of the resultant force is directly proportional to the acceleration that it causes. For example, if you made the resultant force twice as big, then the acceleration that it causes would also be twice as big. We can see this in the equation F equals ma, which says that the resultant force is equal to the mass of the object multiplied by the acceleration that it causes. So if our particle from earlier had a mass of 0.25 kilos and was acted on by a force to the left of 30 newtons and a force to the right of 42 newtons, then we could use this information to work out its acceleration. First, we're to need to find the resultant force, which would be 42 minus 30, so 12 newtons to the right. Then we'd rearrange our equation to get force over mass equals acceleration, and plug in our values to give 12 newtons over 0.25 kilos to get an acceleration of 48 meters per second squared. The last thing we need to cover is the idea of inertia, which is the tendency for the motion of an object to remain unchanged. It's basically just Newton's first law, namely that unless acted on by a resultant force, objects at rest will stay at rest, and objects in motion will stay in motion. Meanwhile, an object's inertial mass measures how difficult it is to change an object's velocity, and we find it by dividing force by acceleration, which is just the equation from Newton's second law again. So basically, a large mass, like the moon, will have a lot of inertia, so will require a really big force to change its velocity. And even then, the acceleration will probably be quite small. Anyway, that's everything for this video. So if you enjoyed it, then try checking out some of our other physics videos. and we'll see you next time.